مساء الخير، وبسعدني أني أرحب فيكم جميعا بالمحاضرة العلمية اللي راح يلقيها المهندس محمد خير. وهاي المحاضرة هي المحاضرة الثالثة من سلسلة المحاضرات اللي بنظمها مجمع المهندسين الكهربائيين والإلكترونيين بالأردن لجمعية الحاسوب بالتعاون مع مشروع تطوير مناهج الذكاء الاصطناعي والروبوتات. بس صحيح انه بالبدايه بدي اشكر الاستاذ الدكتور محمد زكي خضر يلي عرفني على المهندس محمد خير. الدكتور محمد زكي خضر هو استاذ هندسه كهربائيه بالجامعه الاردنيه، وعلاقتي فيه طويله، واشتغلنا مع بعض بأبحاث عديدة لها علاقة بخدمة اللغة العربية باستخدام الذكاء الاصطناعي. وأعلمني الدكتور محمد زكي أنه المهندس محمد خير راح يقوم بزيارة للأردن للمشاركة بمؤتمر بجامعة آل البيت، لكن بسبب ظروف حرب غزة هذا المؤتمر تأجل وحولنا المحاضرة عن بعد. يعني نحن موضوع العدوان على غزة ومعاناة أهلنا بغزة موضوع مؤلم، وبنتمنى لهم النصر والراحة. وإذا سمحتوا لي نقرأ الفاتحة على أرواح الشهداء بغزة. فالبديل كان هو، بما انه ما المهندس محمد خير ما تمكن من انه يجي على الاردن، فكان البديل ان نرتب هاي المحاضره المهمه عن بعد. والمهندس محمد خير انا بعتبره انه باحث متعدد الامكانيات والمهارات، يطور نفسه بشكل مستمر. هو بالاصل بايوميديكال انجينير ومخترع بهذا المجال، له عدد كبير من براءات الاختراع، وبيحمل شهاده البكالوريوس والماجستير بالبايوميديكال انجينيرينج، وبرضه انخرط بالدراسات العليا بافضل الجامعات الامريكيه. ومن بالوقت الحاضر هو CEO of the International Computing Institute for Quran and Islamic Sciences. راح يكون إن شاء الله محاضرة اليوم من شقين، تم اختيارها لأنه هاي المواضيع هي مواضيع بيشتغل فيها المهندس محمد خير، له خبرة رائعة فيها، وبنفس الوقت نحن بتهمنا. الجزء الأولاني راح يكون عن ال Artificial Intelligence Applications for Arabic Language Stylometry.
أعتقد الإنترنت عندهم انقطعت، ممكن نعطي بعض بضع دقائق لإعادة المشاركة.
أوكي. يبدو أنه وأنا بقدمك انقطع الاتصال.
لا ماشي، هلا سامعينك كويس دكتور، تفضل.
أوكي، فأنا ما بعرف وين انقطع الاتصال، لكن برحب فيك مهندس محمد خير بهاي المحاضرة يلي بتتكون من شقين، وتفضل الميكروفون لك.
شكرا جزيلا دكتور غيث عبندة على المقدمة، و يعني سعيد جدا بوجودي معكم إن شاء الله المرة القادمة في شخصيا إن شاء الله بالأردن. قدرنا أن نرتب هذه المحاضرة حتى نحاول أن نعطي بعض العلوم عن التعلم العميق والذكاء الاصطناعي اللي هي متطورة، وفيه دائما في تطور دائم، لكن نحاول نواكب هذا التطور قدر المستطاع بإذن الله ونشر العلم. سأشارك الشرائح الآن. كما ذكر الدكتور غيث، هناك موضوعان نناقشهم اليوم. الأول يتعلق في تطبيقات الذكاء الاصطناعي في التعرف على الأسلوب الكتابي. بهذا الصدد حاولنا أن نسخر هذه التقنية للتعرف على الأسلوب الكتابي في القرآن الكريم وفي الحديث الشريف وفي الشعر. بسم الله الرحمن الرحيم. نبدأ بهذا الموضوع الأول، وثم بعد ذلك سننتقل إلى نماذج اللغة الكبيرة وتطبيقاتها على أيضا في مجال القرآن الكريم والحديث الشريف والعلوم الإسلامية. الشرائح هي بالإنجليزية. سأحاول أن أتكلم بالعربية قدر المستطاع، لكن اعذرونا يعني إذا كان في أي أسئلة على التقديم بالإنجليزية أرجو أن ترفعوا اليد وممكن أن نجيب على أي أسئلة لكم. بالبداية استعمال deep learning methods for classifying linguistic expression style. يعني what is the style of expression in a writing? Obviously we all know يعني القرآن is different, has a different source, هو الله سبحانه وتعالى, different source from the prophet, and different and that the prophet is not a poet. We as Muslims firmly believe that and know that, and as Arabic speaking people, we know that. It's simple. But for a non-Arab speaking person who's maybe not familiar with Arabic, and I live in the United States, so I hear a lot of this all the time. They think that the prophet wrote the book, the Quran himself, and so it's the same arguments that were taking place back 1450 years, where the people of Quraysh used to say the prophet is a poet, right? But we know that in the Quran, Allah has instructed us that He did not create the Quran. He did not. He's not a poet, and so by means of neutral or scientific evidence, we would like to demonstrate the difference between the Quran in its style and the Hadith in its style and the Shar al-Jahili, pre-Islamic poetry in its style. And this is by objective evidence through artificial intelligence techniques, proving what we as Muslims and Arabs already hold as truth and know. The data sources that were used, obviously in the Quran, there are 6,236 verses in the Hafsa and Asim narration, and the Prophet's Hadith. We took Hadith from the Bukhari, pre-processed it to remove the matan from the sanad, and to only use the matan where the Prophet's speech is indicated. So kind of narrowing it down to only the Prophet's speech, sallallahu alayhi wasallam. And to compare it with poetry, we picked المعلقات العشرة بالشعر الجاهلي, شعر قس بن ساعدة. We took those poems that are available to us, and those compose 858 lines of poetry. So that's the source of data that we started with. All this data and code that I will be talking about, it can be accessed through this URL, and we will be sending these slides later on, inshallah, along with the video. To demonstrate that, we used what was known as long short-term memory networks, or LSTM. And long short-term memory networks are featured to hold their recurrent neural networks. However, they have a state information. They keep state information, so they can maintain information for longer periods of time. Therefore, they're good in detection of features that are both short-term as well as long-term, and in their classification application. So they were suitable for this stylometry application. And what essentially given the training of the network happens so that you give it a letter and it provides a context to predict the following letter, or a word, and it provides context to predict the following word. This is kind of in the structure of the LSTM. As I mentioned, there is a state element, and it takes an input data. It generates an output classification data, but also the output is fed back into the state. So there is a feedback loop, which makes it hold more information over time. And there is gates that allows it to be selective about which features it or how much of the input it needs to maintain and how much of the output it needs to output. The architecture of the deep learning network is not too complicated. It's only five steps: an input sequence layer, the bi-LSTM layer, and I'll talk about the bi-directional LSTM in a little bit, and then a fully connected layer for deep learning, and then a selection softmax, probability, a kind of determination layer, and a classification layer. And the LSTM, as I mentioned, is bi-directional. So there's a forward path where we predict the next word. And then there is a backward path where the relationship between this word, the current word, and the previous words are also indicated. So in a bi-LSTM layer, we kind of take advantage of the sequence of relationships bi-directionally, forward and backward. One of the most important aspects of processing Arabic language is how to convert these letters into numbers that the neural network can understand. So there is an encoding step, and essentially it's simple. It's we list all the letters of the Arabic alphabets. We look at a word or a sentence. For example, this ayah min al-Quran, وَمِن شَرِّ حَاسِدٍ إِذَا حَسَدٍ, and we put a 1 on wherever in this sequence, wherever the letter appears, and zeros everywhere else for the other letters. And so you generate this pattern. And so we did this for the entire Quran and all the 5,000 roughly Hadith and the poems. The training is randomized, so the data is shuffled and randomized order, and then sorted and padded to allow for a. So the training set is only a subset of the entire data set. It's you will see that in a later few slides is we took 25% for training, 75% for testing, and then we did another iteration with 20/80, 20 being training and 80% being testing, and even pushed it one more step for trying to see the sensitivity of the learning of the LSTM network. Is we went to 15% training and 85% testing. So again, data is randomized, sorted, padded, and then we train the LSTM until convergence and error reduction. And then we start to do the inference testing after that. So these are the results. As I mentioned, this is an ID number for the network or test that we ran. Here, 2575, 2080 split, and a 1585 split. the higher numbers being for the testing. And usually in most classical deep learning applications, they actually the reverse is done, like where you train on more data and test on the remaining portion, like you train on 80% and test on 20%. But in this case, because of the excellent performance, we went down to reduce the percentage for training down to the 25%, and the remaining of the data, 75%, was used in testing. The really nice result out of this research is that the LSTM this LSTM network had performed really well with high accuracy, exceeding 98% in accuracy for the 25% case of training, and 100%. This 98% was for the Quran and for the Hadith, and for the poems was pretty much 100%. And as we try to test the sensitivity of this, where does this accuracy start to drop as we reduce the training percentage? At 20%, it still performed fantastic. At 15%, it starts to drop. The accuracy of the Quran detection classification was started to drop, but still was excellent for the Hadith and poems. And these essentially show the number of verses used for training versus for testing. And this is kind of just a depiction of the increase in accuracy over the training time and the reduction of the error over the training time. And this is the 25% case, and these are the results. As you see, the diagonal here shows that a Hadith true case, a predicted Hadith, was classified as a Hadith true case, and this is the amount of poems that were actually poems. The diagonal is essentially accurate true positives, and the other cells are the false positives. So essentially, in training, the left graph was the training results, and the right graph is the 75% testing results. We see very few false positives, and the rest were all true positives on all the other verses. So the style, what we take away from this is that the style of the Quran, the style of the Hadith, the style of the poets were very well detected and very well classified in this. And as I mentioned, a test of sensitivity of accuracy versus amount of data used for training. Here we use the 20% for training, 80% for testing. It's still excellent results, very little false positives. And here, this is the 15% case. So I will move to, let's have some closing remarks and take any questions on this section, and before we move to the next section. Essentially, some future research possibilities is to apply the stylometry on across the surahs in the Quran to see if a particular surah has different style that is distinct from the other surahs that the LSTM can detect. Also, we can apply it for Makki versus Madani type surahs to see if there is a difference in any style of expression between Makki and Madani surahs, or between short and long surahs, for example. Also, one of the key interest applications of this is, can we detect a true hadith, a sahih hadith versus a false hadith, or a da'if? Can this technology be applied in that space? So this is an area of research. And there's I would like to give credit to Dr. Halim Sayoud for his kind of stimulating this early thoughts in this research, and for other gentlemen who helped me in sorting out the data and classifying. All the data is available in that link that was provided, and we will send that. I'll send it with the slides, inshallah. Any questions on this section quickly before we move on?
دكتور محمد إذا سمحت لي، مساء الخير.
تفضلي. أهلا وسهلا.
دكتورة سحر عدوان، أنا من الجامعة الهاشمية. شكرا للآي تريبل إي ولإلك إنكم ناديتونا هاي المحاضرة. بس أنا عندي شغلتين كانوا في بالي. أنت جاوبتني على الإشي الأولاني إنه بإيش بقدر أستفيد من هذا التطبيق، بس الشغلتين اللي ضلوا ببالي إنه الأكيورسي كانت كتير عندك عالية. يعني معظم اللي بيشتغلوا في الماشين ليرنينج في ابلكيشنز مختلفة بضل هالأكيورسي عندهم، يعني يحاولوا يزيدوا فيها بطريقة أو بأخرى. فوصولك لل100%، يعني أنا شفت واحدة من النوتس، ما بعرف إذا مفسر من قبلك ولا لا. هاي واحد. واثنين، السلايد تبع التحويل الأحرف لتيبل. طب ما أنت بتعرف دكتور إنه هاي بتوقع الكل بيعرفها، يعني من مشاكل اللغة العربية إنه الحرف إذا عليه ضمة وكسرة وفتحة. فمش عارف، أنا مش عارف إذا هو السلايد أنا لأني شايفته صغير، أنت كونسيدر هذا الموضوع ولا كيف يعني؟ وشكرا لك.
نعم، التشكيل كان يعني حذفنا التشكيل من الكلمات، فالكلمات كانت فقط كما هي بدون تشكيل، يعني بدون حركات. يعني هي زيادة التشكيل حتزيد الدومين عدد الحروف، لكن لا اعتقد انه البرفورمانس راح يتضرر كثير، لانه LSTM performance was very powerful، يعني very good. ممكن حتى انه يوصل لنفس مستوى results maybe with a little bit more training اذا زاد عدد الحروف المستعمله مثلا. لا لانه عندك اختيارات اكثر يعني. ف you have to expand او you can expand the size of the layers to accommodate a higher performance. But I think you can still reach higher. It's an area of improvement for sure يعني. تفضل دكتور. المهندس احمد، تفضل.
الو، يعطيك العافيه دكتور.
اهلا وسهلا.
اهلا بك. انا المهندس احمد المجدوبه، خلصت ماستر، وكانت رسالتي برضو بالماشين ليرنينج وباللغه العربيه فور يعني تشكيل اللغه العربيه وتصحيح الاخطاء الاملائيه. انا بس عندي استفسار دكتور حول الاليه اللي استعملتها علشان تعمل كلين للداتا سيت. هل كان في مشاكل في الداتا سيت اللي استخدمتها؟ استعملت تكنيكس معينة حتى تعمل كليننج للداتا سيت الموجودة؟ ما
يعني
ذكرت عفوا.
الداتا سيت، فصل المتن عن السند كان تشالنجينج، كان كتير يعني صعب، لكن الحمد لله السورس اللي استعملناه كان فيه زي كوتس على أي نص المتن كان من قول الرسول صلى الله عليه وسلم. يعني استعمال هذا النص اللي وجدناه كان سهل علينا كثير استخراج المتن. أيضا بعض الأحاديث مثلا هي عائشة تقول أو رضي الله عنها أو شخص آخر يقول عن الرسول، لكن يعني تحتاج يكون واحد كيرفل لكل واحد من هذه الأحاديث، يختار اللي هي مناسبة لبروسيسنج. وبعض الأحاديث يعني قصيرة جدا، الكلمات اللي تخرج من الرسول قصيرة جدا، بضعة كلمات فقط. الشورت لينث يعني كان تشالنجينج شوي. نعم تفضل.
طيب معلش سامحني دكتور، هل في يعني بعد اذنك حاولت انه يعني تستخدم مثلا الاحاديث القصيره لوحدها، احاديث طويله لوحدها، ايات قصيره، ايات طويله، ولا ما فكرت بهاي الاليه حتى تشوف كيف ممكن يكون اداء الموديل اللي استخدمته؟ يعني عفوا. نعم تفضل.
طيب هو الريزلتس كانت كثير ممتازة، فلم نجد حاجة
نعم
يعني تمييز بين الآيات القصيرة والآيات الطويلة. بعض الأخطاء الفولس بوزيتيف بنشوفها مثلا حاميم.
نعم
طيب
نعم
يعني ما فيش شيء كثير لينث بال تو كلاسيفاي ات ريلي.
نعم
إذا كانت حاميم مش جزء من التريننج داتا سيت، وهي فقط جزء، كل الحميم جزء من التستنج داتا سيت،
نعم
وهو راندمايز باي ذا واي،
نعم
راح يكون صعب التحكيم، يعني هل هي
نعم
حديث أم قرآن
نعم
أم نعم.
نعم. آخر سؤال، سامحني دكتور، أنا آسف
تفضل.
طولت عليك، الله يزيد فضلك. في بعض الحالات اللي ممكن تكون يعني ما بدنا نسميها حالات شاذة أو حالات نادرة، زي ما تفضلت مثلا في الآية القرآنية حاميم، هل لو تم استثنائها عفوا ممكن تصير أداء أحسن في الموديل
ممكن.
نعم
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 ممكن، لكن
نعم
هو يعني بشكل عام يعني مقارنة يعني
نعم.
بالكلاسيكال ريزلتس يعني للديب ليرنينج، أداء ممتاز، كان الأداء ممتاز، فلم نجد يعني حاجة لذلك أيضا.
كل
تفضل.
الشكر دكتور.
يعني عفوا. تفضل دكتور محمد رواشته.
الله يعطيك العافية دكتور.
عافيك.
مهندسنا العزيز، جهودك مشكورة، ما شاء الله
الله.
عليكم. أنا بصراحة عندي أكثر من سؤال. السؤال الأول، لاحظت أنه أنتم بتستخدموا التريننج سيت 25% من الداتا سيت،
نعم
والتستنج 75%، فهذا أتوقع عكس اللي إحنا بجوز نمشي
صحيح.
عليه، بندرب على
صحيح.
الفترة على الكم الأعلى، فليش؟ إيش السبب؟
يعني أنا جربت بالبداية 75%
أنا
كان.
إذا سمحتوا لي ممكن أقاطع. أنا بدي أرحب باللي تكلموا قبل شوي، الدكتور سهيل والمهندس أحمد والمهندس محمد رواشدة. أهلا
الله
وسهلا
يحييك دكتور.
فيكم جميعا،
الله يحييك دكتور.
وكلكم بعرفكم بشكل شخصي.
تحياتي دكتور، كل الاحترام، الله يحفظك.
الله يسعدك، وبعتز فيكم كثير.
الله
أنا
يكرمك.
بدي أقترح إذا سمحتوا إنه نأجل الأسئلة حتى نهاية البرزنتيشن تاعت المهندس محمد
تمام.
خير.
ممتاز. ممتاز.
فإذا ما عندكم
تمام.
مانع، ما لم يكن السؤال يعني في مشكلة أو في يعني only we interrupt for hot questions or major problems, otherwise خلينا نخلي النقاش الموسع والأسئلة بعد ما ينتهي المهندس محمد من تقديمه. وشكرا لتفهمكم.
شكرا جزيلا.
تمام.
ننتقل إن شاء الله للموضوع الثاني إن شاء الله. I'll take your question after بالنهاية إن شاء الله. The next topic كان specialization of large language models اللي هم طبعا more recent advance and about a year old or so بالقرآن و Islamic sciences. How do we apply the utility of large language models in the Quran and Islamic sciences? So what we need to develop, there are three major areas that we need to develop LLM components. Okay, first is data. Can we accumulate the right data, pre-process the data and use it for training, validation, and testing. So availability of data is key, and that's a major effort or focus area in the development process. Second step is the software for deep learning and for parallel computing. Okay. Deep learning models, especially for large language models, tend to be very large in size and require a lot of compute power, but also the software to manage the training session, to fine-tune the hyperparameters of the model. All that software needs to be in place so that when even if I give you hardware and you have data, but you don't have that software ready, you're not going to be able to really do much. So that's the second component, is the software that is capable to scale up on any number of GPUs or for parallel computing to allow you to manage a training session on for a deep learning model. And the third, as I mentioned, is the hardware, which is parallel computing hardware. A lot of times we have maybe one GPU on our PC, maybe none, but leveraging cloud services such as NVIDIA, Lambda Labs, or Google Cloud, we can access, or Amazon, and there's or Microsoft clouds. We can access many GPUs and rent them for a brief period of time. And as I will show and talk a little bit more detail. So what steered this program is that language generation when it comes to Islamic sciences and Quran and Hadith especially, it needs to be factual, reference-based. It cannot have any kind of generative hallucination in it. Ensuring 100% accuracy is absolutely critical for us as Muslims, and we need to ensure that takes place. So, and that's الحديث النبي صلى الله عليه وسلم قال إن كذبا علي ليس ككذب على أحد من كذب علي متعمدا فليتبوأ مقعده من النار. فلذلك we take this very seriously, and we need to make sure that the tools and software we develop ensure accuracy. So how do we control this LLM accuracy? I'll give you a quick this is a ChatGPT. The association, initially a year ago when I tested it for the Quran, I said, give me ayat al-dain. It used to switch words and replace one word with some other word, or drop words, or part of the verse would not be there. And it was extremely horrifying, really. It's what is this? They didn't even test it or think to test it. Now it's improved, but I cannot say with certainty because we did not test all of the Quran 100% with GPT-4. No one has, to my knowledge. And then the association with verse number is still wrong. So, for example, we say ما هي الآية 20 من سورة 20 طه قال ألقاها يا موسى عفوا قال ألقيها يا موسى. وهذه خطأ لأنه هذه الآية 19 وليست 20. 20 فألقاها فإذا هي حية تسعى. فإذا حتى الأسوسيشن with of surah verse number versus with the text is still not there. It's kind of wrong. So how do we control LLMs to produce good results? We've heard a lot about prompt engineering. Defining a system prompt is like selecting a personality of the LLM. As if you think this LLM has 10,000 personalities because of all the volume of data it was trained on. And you need to select that one personality that you're interested in that defines the style of responses and the type of knowledge that it will draw upon to prepare the response to you. That's called prompt engineering. And this is an example of a prompt where you say you're a helpful assistant, help Muslims become stronger in faith. This is a system prompt from the engine called Ansari. You can try it at ansari.chat. It's an effort by Dr. Walid Qadous, who is the Chief Science Officer of a company called Anyscale, anyscale.com in San Francisco. And it's open source, so I invite you to look at the GitHub to learn more about how he constructed Ansari to control it, control GPT-4, essentially. It's built on top of GPT-4. Another simple thing which is should be done easily is setting the temperature to 0. And temperature is a number between 0 to 2. At 0, it's the generation becomes more factual, more realistic, less imaginative, less creative, less hallucinative, in a sense. So that's a simple thing we can do to tune or control the performance of the model. there are a couple of strategies, or three strategies we can follow to control the output of a large language model. The first is a retrieval augmented generation. And what we mean by that is we want to retrieve information from a database. Some database that is validated, authenticated, retrieve information from it and augment or add to the information that we provide to the LLM so that it can generate the final response to the user. RAG tools, there are a number of companies that produce libraries and packages for retrieval augmentation. Most significantly is the langchain.com and llamaindex.ai. Please visit their websites and kind of get familiar with their tools and tool sets and packages. They're free, open source, and you can use them in your development of applications with LLMs. The second is a plugin, or that is essentially a function calling. You use, and this is available in commercial LLMs. Unfortunately, not so in open source LLMs like Llama 2, but it can be added. You can add it by fine-tuning this feature of function calling. And what is function calling is essentially ability to call a function and provide execute software that you have that allows the access to a database to bring in information to the LLM. So, but like I said, this is kind of a real-time kind of bringing in information. So similar to RAG, but it was done on the commercial LLMs like OpenAI, GPT-4, and I'll show you an example of that in a bit. And then fine-tuning is essentially a retraining or specialization, incremental training of large language models. So large language model training, when we say training, that means you start from scratch, from totally randomized weights, and you're trying to achieve a stable point of error reduction. But fine-tuning is taking that already trained model and retraining a portion of it, fine-tuning it with some new knowledge or new information. And we'll talk about that. One of our interests in fine-tuning was taking the resources of Al-Maktaba Al-Shamila, around 40,000 books, and to improve the contents and model response to user queries of these large language models. Particularly, we're interested in Llama 2 because of its open source. These are just a display of what are some of the commercial LLMs, ChatGPT and GPT-4, Bard from Google, it's also known as Palm, and Cloud 2 from a company called Anthropic in the UK. And then there is open source models, which are more interesting for us because they're freely available. The Llama 2 is from Meta, a company called Meta, which is Facebook essentially, and comes in 3 sizes: 7 billion parameter, 13 billion parameter, and 70 billion parameters. Unfortunately, and I'll show in a slide later, its Arabic is not very good. You ask it a question in Arabic, it responds in English. So it's not, it needs a little bit more fine-tuning, a little more help and kind of fine-tuning on Arabic language. I was hoping Falcon would speak Arabic well. Unfortunately not. Falcon is from the United Arab Emirates and doesn't speak Arabic. Also, it comes in 3 sizes, much bigger than the Llama. So the biggest size is much bigger. The bigger the size, as we will see, performance improves, but not necessarily. It really depends on the optimization, on the network structure, and we will examine some models like this Mistral 7B that does really well, and it's, even though it's only 7 billion parameters in size, a smaller size. these sizes require a lot of memory. 7 billion parameter, each parameter is 32-bit. You can imagine the size of 4 bytes. So you need at least 28 gigabytes, to support a 7 billion parameter model. Well, how do we take these models and train them with this? So we'll examine some techniques that are economical that allows us to to fine-tune these models. Llama 2, here's the list of languages it was trained on. Arabic is not even among, although it was trained on Arabic, but it's less than 0.01%. Almost 90% of it is English, as you see. And this shows that the bigger the model size, Llama 2, there was Llama 1 before and then Llama 2 after. But the biggest model, the 70B, is the best performing one, although, again, bigger size, more memory, more hardware, more cost. We like to go with the maybe 13B, يعني خير الأمور أوسطها, ربما, and we try 13B is probably almost equally performing to 70B, so it's not so bad, and much better than the 7B. This is how much time it took to train Llama 2. So I give you these numbers for reference. So if you start training from scratch, this is how many hours of training that it takes, and all this is cost, obviously, number of GPUs, this is GPU hours. So you divide this by how many GPUs you have available, and that's how much time it will take to train from scratch. But whenever we want to customize a large language model, we don't want to spend this much time. We want to just fine-tune, only add a feature, add a little improvement to it. And so that's why open source models are important, so that we can leverage them at reduced cost. So first I'll talk about the plugin, and I'm going to move a little fast so that we can leave some space for questions. A plugin, as I mentioned, if I open, here's my ChatGPT, there's a plugin called Sahih AI, and if you install this plugin in your GPT, and you ask ما هو الحديث عن أركان الإسلام, it gives me the English, the Arabic, and the source. It actually executed the plugin here. So this response is from the Sahih AI plugin. Is using RAG, or retrieval augmentation, where it's going to a database, bringing in from a database this text and feeding it or providing it to the LLM to display to the user. Okay, so this is an example of Sahih AI in action. It's open source. It's by Mr. Mohammad Al-Dulaimi. He's from Iraq. He lives in Turkey, or Turkey, I should say. There's another one called Hadith Advice from Fardim Munir. He's from Bangladesh, lives in New York. And both of them are members of our institute. And we are trying to develop a plugin for the Quran as well, for OpenAI to use, and hopefully influence them to make that plugin a default, inshallah. There are some links here about OpenAI function calling structure and utility. LLM2 does not often, Llama 2 does not provide function calling, but you can, with this script, and here's a video of it, you can fine-tune Llama 2 to make function calling available to it. In which way you can then, once there are trigger points in the prompt or the response that requires it to access it invokes it to access a query. It's essentially if the query from the user matches the description of the function, then it goes out and invokes that function to execute an SQL query, bring in the result, and provide the response to the user. This is an example of a function call. You describe a function, its description, its arguments, input and output arguments, and here's an example of how how you would call or invoke that function. And so, for example, you would use anytime the user says قال تعالى, قال سبحانه, ayah, surah, bismillah ar-Rahman ar-Rahim. When you mention Quran or Hadith, immediately you can invoke these functions for the plugin to bring in the text. This is what I was just showing you, so I'm going to skip that. In data preparation, there is the text, the data that you provide for fine-tuning LLMs needs to be prepared in JSON format. And these JSON formats would essentially describe the text. It could be a question-answer pair. So, for example, if you're trying to create a chat engine and you're trying to give the model ability to answer questions, then you give it a few question-answer pairs, maybe a few hundreds of those, and that's how you enable that that feature to be added to the LLM. LLMs originally, they're trained on body of text, like millions of pages or sentences. They don't go about creating questions answers. Rather, they use sentence completion. So they train on part of the sentence and predict the next word, and then add that predicted word, to the rest of the to the prior sentence, and predict the next word again. So the sentence completion is the normal mode of training on large body of text. However, if we at the end of that training, now that it gained the knowledge, to give it the skill of question answering, we have to fine-tune it on question answering pairs. And similarly for language translation, you give it a pairs of language translation and fine-tune it on that, and it adds that skill. Much the same for text summary or story writing skill. Those are all skills. And every time you fine-tune it, you add a skill set to that LLM. Tokenization is another important part where you take the input text and you kind of split it into not only into each words, but parts of a word. That a word could be a compound word or has a appendix to it. Some letters that are appended to it or prepended to it. And so splitting it into its constructs allows us to tokenize, and the tokenization is really specific to every language. So Arabic has tokenizers, and there are two engines on Hugging Face called Arabert and Camelbert that provide tokenization for Arabic. Those are from the American University in Beirut. Developed these. So I think we can leverage the tokenizers in these, or we can improve upon them as well. Using, for example, I know in the University of Jordan, there's a lot of software developed for Sarf, and we can use the Tahlil Sarf to split the parts of a word and all of that, and leverage that as a tokenizer. Hugging Face, just a comment for those who don't know, huggingface.co is a website that really is the world's largest open source repository for LLM models, code, and data. So please get familiar with it. Once we tokenize, we are essentially converting these parts of a word or words into a number, a vector number. Okay? And that vector number is a numeric representation of that word. And it provides what's known as data embeddings, أو تضمين القواعد الأرقام. And we store the data embeddings in the vector databases. A vector database is a database that contains multiple types of data. So that's why it's called vector. It's because it can contain text, audio, video, images, any kind of data. That's why we call it vector databases. And those are essentially Chroma, Pinecone, Deep Lake, and Vice are examples. There are many more, but those are famous ones. And each of those can be accessed at their websites as well. Some of them open source and free. Fine-tuning process, essentially, which is one of the, and I'll try to move faster here, is the CLORA or quantization low-rank adapter has become really almost the standard of a fine-tuning technique. In quantization, we instead of representing each of the weights of the network, if you have 7 billion or 13 billion parameters, instead of each weight being 32-bit, now we can reduce it to 8-bit or 4-bit even. And in this paper that I referenced, it shows that the performance isn't really affected much. So yeah, there's a slight reduction in performance, but generally speaking, it's not significant. And so we can leverage quantization, give each weight to be 8-bit or 4-bit to speed up the calculations, to reduce the memory requirement, and reduce the cost, time and cost on the use of the hardware. And low rank, essentially, it's a technique where we select essentially that's the LoRa in CLORA. The low rank, we select a subset of the weights to fine tune. We don't, and leave everything else unchanged. So the weights that are impacted by the new knowledge we add, those are the only subset that are fine-tuned and leave everything else intact. So that allows you to speed up fine-tuning. Maybe a good example of this CLORA application, there's called Ludwig, and this is an open source free package from Uber, a big company for transportation. It can speed up fine-tuning by 50 times efficiency. And there are other, and this is the kind of open source links for that. There's also some open source from Hugging Face on other open sources that are available on these links. You can check them out. And finally, once we have trained the model and we have a model, then we want to host it on a web. And so you need some web interface to present it. And this is the web screen for Ansari engine, chat engine. And you can see that in its GitHub repository as well. Finally, I want to talk about software, and this is for training. And Anyscale.com is becoming really the go-to company by all big corporations that are developing large language models, including OpenAI and Cohere and Uber and LinkedIn and many others. But it's because the reason is they offer excellent this Ray platform. The Ray platform is a way to orchestrate the training and the serving of large language models or any deep learning models for that matter on big compute platforms. And they work on any cloud, so they can easily you can install their software on NVIDIA cloud or Google cloud or Amazon clouds or Microsoft clouds. The Ray platform offers you software tools to very quickly be able to prepare the data, train the large language model, tune any hyperparameters, and serve the model. it orchestrates the training session across many GPUs. So for you as a user, you don't need to worry about how many CPUs, how many GPUs, how many TPUs. You know, even if you have one GPU or 1,000 or 10,000 GPUs, it's transparent to you, and it's all managed and orchestrated by the Ray platform. This is important because as you're training, you don't want to worry about if one GPU had a fault, then all of your training session and training data is all gone. All your, it's all wasted. So you want to have some fault tolerance, and that's what a Ray platform allows you, as well as parallel computing capability. Also, in terms of hosting, if you've fine-tuned the Llama 2 model, a million token, serving a million token on their through Racer costs only $1, lowest cost in the industry, and Mistral 7B is only 15 cents per a million token, so very good price point. These are just, I'm going to skip some of these. This is in a few lines how you can prepare data, train the model, tune any hyperparameters in training session, and then serve the model. So really very, very only a handful short script, and you can do significantly a lot using the Ray platform. Integration of large language models. Now, if you have a large language model, now you want to serve it as an application, and essentially using LangChain and Llama Index gives you tools, agents that allows you to make this LLM model access the internet or access a database or have access to your own local files, like if you have PDF files, Word documents, Excel sheets, whatever you have on your local drive, and you wanna be able to read those and feed them into the LLM. LangChain, particularly, I love LangChain, but Llama Index 2 is very good. And they give you all these tool sets to access these. They interact with your own environment, leveraging RAG or retrieval augmentation to feed data to the LLM and make it more lively it's not just limited to the data it was trained on. Now it's interacting with your environment. I'm going to skip some of those, but this just shows how you can train multiple GPUs in parallel with Rayscale, and some links on that. All right. Training price point of NVIDIA Lambda Labs is only $2 an hour per GPU, and it's the lowest in the industry. And like I said, Grayscale also integrates with NVIDIA. You can also do Google Cloud for computing. This link is for if you apply on this link, they'll give you 5 GPUs for 1 month for free to use on the Google Cloud. So very nice for research, or whoever has an idea for research, please apply and leverage that free resource. And then you have Amazon Web Services and Microsoft Web Services that are also a little bit more pricey than NVIDIA's, but they're there. Just want to show this is the price point of you renting an H100 for only $2 an hour, or 8 H100s cluster for $20 an hour. H100 is the highest, the state of the art of the computing industry in terms of performance right now as a GPU. And these are just general numbers that you should know as you're developing, kind of have a reference understanding of the cost and price and GPU memory requirements, etc., for LLM development. Finally, I just want to give pointers to in the large language models are not only good for general query of information. They're really been trained on coding, and AI coding development or software development using AI has become the trend and the future really for software development. So Not only we as obviously we are the pilots, we should know programming languages really well, but you need to leverage these AI tools to accelerate your work and be more productive. And it's important to understand how to use them as a tool, not to replace you, but more as a tool, because they're still obviously short on their capabilities. But please check out AutoGen and MemGPT. AutoGen is a tool from Microsoft that allows you to run parallel computing agents. And MemGPT allows you to extend the context window of LLM. So essentially, instead of having 16K tokens available to a LLM prompt, now you have infinite memory, and you can have infinite. You can give it large volume of information and data, and still retain that memory or access to that memory. This field is very fast. Stay up to date and stay up to pace with it. All the development happens really quickly in this field. Open source AI resources are wonderful. Please leverage them. Apply them on large language models, particularly to the surface of Quran and Islamic sciences. There are many innovative projects that we have at the Quran Computing .org organization, our Quran Computing Institute. Please join us with a free membership. And there's a link under the menu in the website for membership. LLM is a new field. I think that means there's a lot of innovation opportunities. I want to ask the audience, are smaller personalized large language models, maybe on mobile devices, better than larger general LLMs in the cloud? What do you think? I would love to learn your opinion. And if they are better, what architecture can enable smaller personalized LLM models to be more efficient, productive, and knowledgeable? And thank you very much for your participation today. And I'll take any questions. I'll address the previous question, but I don't know if I remember it well. I think it was about the accuracy and why we use 25% for training. It's really, I started with 75%, and so the performance really very good. I said, well, I'll challenge it a little bit. So we started with 50% training, 50% testing. The performance was still good. Went down to 30, 40, 30, and then 25%. And, that was really good. And I wanted to test the sensitivity of when does the accuracy of the LSTM network starts to be affected. And turns out to be still running really well, even down to 25% of the data used for training. The code is available in that zip file. It's all in MATLAB, by the way. But it just kind of outlines the structure of the LSTM and that is done. That was MATLAB code, wasn't Python, unfortunately. But those who have MATLAB can run it. Yep. Go ahead, please. رقية.
يعطيك العافية. Can I ask in Arabic?
Sure, أكيد.
عن جد انبسطت بالمحاضرة اللي كانت اليوم، المعلومات القيمة. بتمنى يكون في كمان لقاءات تانية.
إن شاء الله. إن شاء الله. تسلم. يعني إحنا بالمعهد بنعمل كثير محاضرات مش عندنا مشاريع كثيرة الحمد لله. We also need help, volunteers. We have some students who volunteer. I invite all of you to be members of the Quran Computing Institute and reach out to me on my email, if you're interested in participating in any of the projects we do.
مساء الخير. مهندس محمد رواشدي، أنت كنت بدك تسأل أكثر من سؤال والأولاني جاوبه المهندس محمد خير. بتحب تكمل أسئلتك؟
أشكرك دكتور غيث لهذه الذكرى، وأشكر الدكتور محمد خير للفروتفول سيشن. بصراحة الموضوع القرآن والحديث واللغة العربية بشكل عام هذا موضوع بصراحة يستحوذ على اهتمام الكثير من الناس وأنا منهم. لذلك اسمح لي مهندس محمد خير أني أسألك بعض الأسئلة في
أكيد تفضل.
البروجكت اللي عملتوه. مشكورين. السؤال، أنتوا لما عملتوا التست للموديل اللي دربتوه عملتوا له تيست من الداتا سيت اللي أنتوا جمعتوها أوريدي من القرآن أو من الحديث أو من الشعر الفصيح المعلقات، صحيح؟
صحيح صحيح.
ما استخدمتوا شيء خارج خارج
لا،
هاي
بس
الداتا سيت؟
that's it. بس القرآن والحديث، متن الحديث
نعم
والمعلقات.
تمام. فلو استخدمتوا شيء خارج الداتا سيت هاي، مثلا من القرآن المحرف، قرآن مسيلمة، أو من الأحاديث الضعاف أو الموضوعة، بتشوف البرفورمانس كيف ما تستوا هذا الكلام؟
لا يعني احنا ما الحديث كله كان من الحديث البخاري، حديث صحيح.
نعم
يعني اعتقد انه يعني مقارنة الحديث الصحيح بالحديث الضعيف يعني موضوع بحث ممكن، ويعني ممكن أشجع البحث فيه. يعني to reach good results، يعني ربما يكون challenging شوية أكثر، لكن باهتمامنا، يعني موضوع اهتمامنا.
تمام.
فممكن نتعاون مع أي حد على ده، يعني الوصول لنتائج لذلك، إذا في حدا انترستد بأنه يعمل عليه.
ممتاز. هل
أنا بحب
أعطيتم
لو سمحت أنا تعقيب على هذا السؤال. أنا حصلت على نتائج بالدعم اللي حصل عليهم المهندس محمد لما حاولنا أن نبني برضو باي دايركشنال STM نتورك حتى تصنف النصوص العربية لبحور الشعر المختلفة والنثر. وبرضو كانت يعني الباي دايركشنال نيورال نتوركس بتدريب معقول are very powerful مع اللغة العربية لاكتشاف الستايل، اكتشاف النوع، هل
صحيح.
هو البحر الطويل ولا الوافر أو غيره من البحور ال17. وببساطة بتقدر إنها تميز بين الشعر والنثر. ودراسة المهندس محمد هي شبيهة، لكن واضح انه الباي دايركشنال STM are very powerful and they can differentiate between poetry, قرآن and حديث. Thank you.
جميل، مشكور دكتور غيث. طيب هل توصلتوا نفس الشيء انه 25% of training set is enough to predict rather than 75؟
لا احتجنا الداتا كلياتها، لانه في بعض بحور الشعر نادر استخدامها والعينات المتوفرة للتدريب قليلة، فاحتجنا ان نستخدم تقريبا كل الموجود.
جميل، بارك فيك.
شكرا.
مهندس محمد غيث، سؤال أخير وأنا آسف على الإطالة. الآيات المتشابهة هل واجهتوا فيها مشكلة بالتعامل معها أثناء تدريب الموديل ولا لا؟ احنا بنعرف في آيات متشابهة تختلف كلمة، بتختلف، بصير تقديم وتأخير. كيف
يعني
تعاملتم مع آيات متشابهة؟
نعم، هو يعني التصنيف كان هل هو قرآن حديث أم شعر. ما كنا نصنف بين القرآن هل هو مثلا مكي أو مدني، أو يعني هاي تطبيقات لأبحاث مستقبلية، ومنشجع الجميع أن يعني يهتم فيها. أو مثلا بعض الصور، مثلا سورة القمر يعني لها أسلوب قوي خاص، الوزن اللي تتبعه. هل تستطيع الإسلام التفرقة بين الأسلوب اللغوي لبعض السور، سورة الرحمن مثلا عن غيرها؟ نحن يعني عرب نعرف اللغة العربية جيدا، نعرف أن لها أسلوب خاص، لكن هل الآلة تستطيع أن تحدد ذلك أيضا؟ نعم.
كل الشكر.
شكرا. أي أسئلة أخرى يعني أهلا وسهلا فيكم.
إذا ما في أسئلة أخرى اسمحوا لي بنهاية هذه المحاضرة إني أشكر المهندس محمد خير الشكر الجزيل على هذه المحاضرة الرائعة الغنية بالمعلومات، وشكرا أيضا لاستعدادك أنك تشاركنا بالسلايدات اللي استخدمتهم، وإذا تكرمت تبعث لي إياهم. أنا عندي الإيميل أدريسز للمشاركين وبقدر إني أوزع عليهم. فمرة ثانية شكرا لك وبارك الله فيك على جهودك الرائعة اللي بتعملها ومشاركتنا بعلمك. فشكرا لك. بالنسبة
شكرا
لك
للدعوة وشكرا للمشاركين. شكرا.
many thanks. نحن بالنسبة لنا بتقدر تقول لنا تصبحوا على خير، ونحن بنقول لك نهارك سعيد.
شكرا. تسلم يا رب. السلام عليكم ورحمة الله وبركاته.
والسلام عليكم ورحمة الله. مع السلامة.